Hello grade 8s, this is a little video to help guide you through the Don't Fence Me In activity. We've already spent a lesson having a look at it, so I will quickly review what the activity is all about, the investigation, and hopefully give you enough clues so that you can complete the investigation in the one lesson you have left for it. So it's called Don't Fence Me In, and it's about trying to find the biggest possible area given 48 meters of movable fencing. That's basically it in a nutshell. And we're told, if we have a look at this side of the screen here, we are told that the kinds of areas that we're looking at are a freestanding rectangular pen, where all four sides of the rectangle are made from the movable fencing, or a rectangle backed onto a barrier. That could be, e.g., I don't know, a fixed fence or the side of a barn or something like that. A rectangular pen where we've got two sides made from the movable fencing and the other two sides are barriers, like, I don't know, could be the corner of some sort of building, or it could be again two fixed fences in a paddock. And then lastly, looking at a right triangular pen, so right triangular, right angled triangle, using an existing barrier, like so. So we've got 48 meters of movable fencing, so the total length of these thin lines here have to be 48 meters, like so. Okay, so that's it. That's what we have to do. And what we're going to do is we're going to take, I guess, each little sub-problem and model it mathematically, and then use spreadsheets to work out the maximum. So here we go. So what I've done here on the second page is this is the answers, and what we're going to do is we're going to just guide you through pen A, and I'll just uncover these as we go along. So you will effectively have the answers to pen A here, but the idea is really, if you can get pen A going and understood, then you should be okay with, well, it takes more thought, but with pen B, C, and D. Okay, so pen A is the freestanding pen. So we've got 48 meters of fencing. So if we call the width X, so remember we can use variables to describe unknowns, okay, or things that vary. So we're going to look at variable widths of the pen, and then we'll see what the areas look like when we change this width. Let me see if I can just zoom up on that rectangle. I might not be able to. Let's have a look at this. There we go. So there we go. So there's our rectangle, and you can see that already we've got a 24 minus x written here. And that kind of makes sense. I mean, if the whole thing has to be 48 meters, because this is a rectangle, these two sides have to be 24 meters. So if one of the lengths is x, then the other length has to be 24 minus x. Note that even though I kind of call the width x, it's just one of the lengths of a rectangle. Rectangles have two equal lengths and two other lengths that are also equal, and they're opposite each other. That's how rectangles work. But for convenience sake, we call one width and the other one length, so we're not calling them length and other length. So this width here, this so-called width, could actually be longer than this length here. But this is an example of the pen where if this were the width that we call x, then the length would be 24 take x, because this length and this length has to be 24. So that's okay. So what we've done is we've started to model the problem using algebra. We've basically we've got 48 meters to play with. The width has to be something, which we're going to change to see what happens to the area. So because it's a something, we call it x. And then we say, well, if that something is x, what's the other side going to be? And it has to be 24 take x because of what I said before. Alrighty, so what is the greatest possible value of x? what is the least possible value of x, and what is the length of the pen in terms of x. When you see that in terms of x, it means that the length needs to be described using the variable x. No other variable. Don't suddenly add in an L or something else. Okay, the greatest possible value of x. Now you'll see here that the greatest possible value of x is written as 24. Now we should say, let's just assume that they're in meter lengths, this movable fencing. The greatest possible value of x is actually 23. Because if the length of this was 24, there'd be nothing left for this length here. Okay, if this is 24, this would be 24, take 24, which is 0. So you'd have one long bit of fence and another long bit of fence with nothing in between. And unless you've got extremely skinny sheep, that's no good for us. But what x equals 24 does represent is an extreme value. It's the first value that x can't be, or the biggest value. It's the first biggest value that x can't be. Okay, so what's the least possible value of x? It's the same idea. You could probably think of x being equal to 1 as being the smallest possible value of x, but in terms of extreme values, what would x be? What's the smallest value that x can't be? Give you a second to think about it. Okay, if you said 0, you would be correcto. So that's all right. So 24 and 0 are the extreme ends of the ranges of values for x. Can't be 0, can't be 24. If you could imagine the fencing could actually be any kind of length, not just meter lengths, then in theory you could have 23.999 meters of fencing. And then this would be 0.0001 meters wide. So that's the theory. Okay, so in terms of x, what is the length of the pen? Well, we're told here already, aren't we? We worked that out before. 24 minus x. I hope it says. There we go. Length equals 24, take x. So there you go. That's the answers to A, B, and C there, and I hope that makes sense how they were constructed. All right, let's put that square to one side for a sec. Come back to it. So in terms of x, what is the area of the pen? So again, we see that phrase in terms of x, which means that we might take a couple of steps to get there, but it's really saying, well, what's the area of the pen, and can we describe that area using only x and nothing else? So for example, you should know what the area of any rectangle is. It's length times width, right? So what we're going to do is we're going to say, well, how do I represent length as an expression with just x in it? How do I express width as an expression just with x in it? And don't forget, length times width is the same as width times length. It doesn't matter which way we multiply them. So if we have area equals length times width, well, guess what? We've got a value for the width and we've got a value for the length. So the area of the pen is going to be these two things multiplied together. And I wonder what that would look like. What's going to be underneath this blue rectangle here? All right, I feel like it's play school. Let's see what's through the rectangle window. There we go. I'll see if I can zoom up on that as well so you can sort of see that in a bit more detail. So we've done some work on expansions, but there's your width, there's your length. We've got to keep the 24 take x together, so we put brackets in there. And we know that between the x and the bracket is multiplication. So this is literally area equals width times length. And like I said, it doesn't really matter length, width, length. So you can literally just say length times width. It doesn't matter. And what we've got here is we have factorized, sorry, wrong way around. We have expanded that particular expression. So x times 24 is 24x, x times x is x squared, and I've carried the takeaway through. So I've just simply expanded that to give us an expression here, 24x minus x squared. Okay, that's the mathematical modelling done for the time being. Okay, so what we've got is we've got a consideration of the minimum and maximum, okay, smallest to largest in the extremes. we have used a variable to describe one of the sides, and then used that variable to describe the other side, and there it is there. And then we've used that information to come up with an expression for the area. So all of that is effectively what we call mathematical modeling. We now have a model that we can use to calculate different areas of this rectangular pen given a value for x. Now, E, F, G is all about using the spreadsheets. So that's why I've got over here the spreadsheet that I gave you. I'm just going to save this and call it answers. How do I do that? I can't remember. Duplicate, isn't it? Make a copy, that'll do it. Don't fence me in solutions. Just so I don't accidentally make changes to the document that you're working on, which I shouldn't do, but... Okay, so in the Don't Fence Me in Solutions, we're now going to take the mathematical model that we have just built up, and we are now going to investigate different areas. So, as you can see in the spreadsheet, we've got width, length, and area. Now this second width here is purely to help us with our graphing later on. The main three are width, length, and area. And I'm under this tab here which says pen A. Note that you've got a pen for each of the rectangles that we're going to be, or not rectangles, the last one's a triangle, for each of the areas we're going to be looking at. Okay, so there's our width, 0, 1, 2. How far do we need to go? We need to increase this list all the way up to 24. So note that I already started it off for you from 0. That was the extreme least, and now we're going to go to the extreme most. So I'm going to select those 3 cells, and then I'm just going to drag it down until I get to 24, a bit longer. There we go, down to 24. So they're my extremes. And what I've done here in this column here, just so you can see it, I've got equals A2. So what it does, it says I'll look in here and I'll put it in there. So if I, for some reason, did change it, this value would change as well. So that's the benefit of doing that, but you might have noticed I didn't quite make it. So I'll just select the last cell. Then when it's a formula, you can just select the last cell, drag it down, and there we go. Okay, we need to work out the length is. What is the length if the width is 0? What is the length if the width is 1? And so on. So we've done the hard work over here. We said that the length is 24 take x. Now you can't just go 24 take away x like this. The spreadsheet doesn't know what x is. It has no concept of what x means. So 24-x will just be treated like a bit of text as far as the spreadsheet's concerned. The spreadsheet needs to know a couple of things. First of all, it needs to know we're doing a calculation. So we start off at the calculation with an equals. So that tells the spreadsheet that's what we're doing. Now if I go 24 take x, oh, I'm getting something weird. That's not right. No, won't let me. What about a lowercase x? No, won't let me do that either. Okay, the reason why is because it has no idea what x is. Instead, what we're trying to do is we're trying to say, well, I'm going to take away the different values that I'm using for x. And this is in this column here. This is our x column, if you like. So what I can do is 24 take away, and now I put a cell reference in. I can either type it in, like so, or I can click. Either way will get me there. And when I press the return key, there's the formula. Again, if I change the value of this here, this length here changes. That's the bonus of it. Okay, so 24 is the length if the width is 0, we know that. So now what I'm going to do is I'm going to use my handle again, and that will copy the formula all the way down, oops, a bit too far, to 24. Okay, so the bonus of using spreadsheets is that when you use cell references like A2, then when you copy the formula down, the cell reference keeps up with it. So great, we've got our width, we've got our corresponding length, we've duplicated the width over here for graphing purposes for later, and now we have to work out the area. Now there's 2 things you can do. You can either take the formula that you've used there, or that you worked out there, and type it in here, and that will definitely give you the right answer. Or you can simply say, I've already worked out the length, I already know the width, and so to work out the area, I simply multiply them together. And again, you can't go length times width. You'll get an error message. That's a huh? Okay, it doesn't know what L is, it doesn't know what W is, and X, of course, is just the letter X, it doesn't know its times. So we don't use variables, we use cell references. Where's the length? Well, I'll go width first, because it doesn't really matter which way, and I just want to keep it in order. So where's the width? Here it is. So I click on it, or I could have typed in A2. I'm going to multiply, so I use Shift 8 to get the asterisk. That's the multiplication symbol on a spreadsheet. And then I'm going to click on B2 or type in B2, either way. I've got it lowercase there, doesn't matter. So it's A2 times B2, width times length. Press enter, and I get an area of 0 meters squared. So let me just fill down a few formulas there so you can see that in action. So an area of 0, an area of 23, an area of 44, an area of 63, and an area of 80 square meters. Now, just to prove to you, you don't have to do this yourself, but this is just to show you, if I actually use this formula here, which is 24x minus x squared, it will work. I'll show you. Equals 24x, that means 24 times x, right? Where is x? It's there. 24x minus x squared. There's the value for x, it's an A2, and I'm squaring it, so I use Shift 6 to say to the power of, and 2 to say it's to the power of 2. Press enter, I get 0 there, and if I fill this formula down, see, it gives me the same values. So I can either use the mathematical model I worked out from over here, or if I don't want to do that, I can simply just use my knowledge of width times length is what area is. So I'll clear these out because we don't need these. I was just doing that to show you that you can do that. Okay, now I need to fill this formula down. So I can just go over the ones I've already put down, doesn't matter. Down we go, don't go too far. And there we go. And unsurprisingly, when the width is 0, the area is 0. There is no area if we don't actually have a width there. And when the width is 24, the length is 0. And therefore we have no area, because it would basically mean the two widths would be next to each other with nothing in between. So that's not too surprising that the extremes are 0. But what we want to do is we want to see what this looks like as a graph. Now, in this particular one, it wants you to do a length versus width graph, and then an area versus width graph. So that's what we're going to do first of all. Now, typically, your independent variable is the variable that goes, that is the horizontal axis, the one that goes that way. Okay? Dependent variable is the one that goes up ways. So when we've got a length versus width graph, width is our independent variable. It's the thing that we have controlled, the thing that we have deliberately changed. And the length, being a formula, changes as a result. So length, the value for the length depends on what we put in for the value for the width. So length is dependent and area is dependent on the width. So it does say make a chart from make a chart. Now the instructions here are for Excel, whereas we're using Google Spreadsheets, but the idea is the same. So I'll just quickly take you through that. I'm making a width versus length, or a length versus width graph. So I'm going to select all the cells that I want to graph, so including the headings. And then I'm going to, now I've got half screen here, so I might just go to a full screen so you can sort of see this. In the toolbar here, you'll find the chart button, or if it's not there for some reason, you'll find it under the insert menu, and there's chart there. And what it will do is it will do a couple of things. It will normally assume that you're using both columns as data, and it will then choose what it thinks is the best. kind of graph. But so we'll just change that. So we'll go to chart types, and it says use row 1 as headers. Yep, that's good. That's row 1 there, so it's using that as headers, so width and length, perfect. It says use column 1 as labels. Yep, we do want to use column 1 as labels, so column 1 for the widths, we want these to be used here, so that's good. We want to use a smooth line graph, like so. It'll say scatter chart or scatter graph in the instructions, or scatter plot, but I think a smooth line chart's good, to be honest. There's lots of different graph types, including a scatter chart. But yeah, I think a smooth line looks good. And then it's probably worth just leaving it at that. You can go to customization and do things like give it a good chart. So chart name. So for example, I could put pen A in square brackets there to say, just so I know what that's all about. And I can do things like turn off. I can even remember where it is. Oh yeah, under legend, I can turn that off because we're only if we were charting 2 different lines, it'd be worth having on there, but we've only got 1 line. So there you go. So as the width, this is not too surprising, I hope you can see, as the width increases, the length decreases. So I'm going to click on insert. So I've got the graph there. I wouldn't waste too much time getting the graph looking right, because we actually just want to see what the graph looks like. So we can see it goes from 24, 0 to 24, and from 0 to 20, that's got to be 24, doesn't it? Down in a straight line. Okay, so like I said, we don't want to spend too much time on that graph, because I'll just go and drag it over to this side so that we can see it when I've got the windows side by side. You're not going to be, I'm going to have a look at your spreadsheets, your Google spreadsheets, but you're not going to be submitting this as part of your report. What you're going to be doing is you're going to be drawing graphs on the worksheet that you've already got. And I think in your copy of Don't Fence Me, and I'm pretty sure it says specifically the word sketch, even though it says draw the graph here. So I wanted to talk to you a moment about sketching. There are 2 ways you can draw a graph. One is by plotting, and the other is by sketching. When you plot a graph, you need graph paper, and you literally divide the axes into specific points along the horizontal and along the vertical, and you look for the coordinates and put dots there on the coordinates, and then you join the dots up to create your graph. It's accurate, but it's also time consuming and oftentimes not necessary. Usually, when you draw a graph, it's simply to give the reader an idea about what's happening with the data. So usually it's enough to do a sketch. And what a sketch does is it just highlights the important information about the graph. So looking at this graph here, I wonder what you think might be the important bits of information. Have a think about it. Alright, so when you sketch, you don't measure off with the ruler. You might feel like you want to do that just to do a really good job, but it's actually not what we want. You keep it roughly in proportion. So as you can see, this one goes from 0 to 24 and 0 to 24. So you want 24 to be on the scale somewhere. You keep it roughly in proportion. If it's a straight line graph, then obviously draw a straight line and definitely still use a ruler for it. But it's not about plotting individual little points along the line. It's literally just drawing the line straight out. Let's see if you have got it right for the information that's needed. Here we go. Ta-da! So the graph is labelled, length and width. Here and here, you'll see that the coordinates for where it goes through this here, what we call the vertical axis or the y-axis sometimes, and the horizontal axis or the x-axis sometimes, these 2 points are critical points. so they are labelled and the graph has been drawn. You know, I mean, if I measured that distance there, it's not going to be precisely the same as this distance here. That's not so important. What is important is that we've got the right shape of the graph. It's a straight line that's going down, and that is a good sketch. That's all that you need to do. Okay, I'll leave that one over there. I'll pop that back over there. Doesn't matter if you don't see it. The next one is create a line graph. This is an XY line graph. It's the same kind of graph as we've done here, of area versus width. It says draw the graph in pencil, sketch it to be precise. So let me go back to the spreadsheet. This is area versus width. Again, width is still the independent variable, area is dependent. So there's my length versus width for pen A. Just drag that over. Oh, it doesn't want to go. Come on. There we go. So we're going to draw another one, but this time, instead of width versus length, we're going to do width versus area. And this is why we put another width column in here, so that we could easily graph it without, when they're not next to each other, although it's possible to graph them, it becomes a bit tricky. So I've selected my cells, my columns, insert chart. This time I've do it from the button bar. Now this time, if you have a look at this rough idea here, this is what our graph is going to look like, which is good, like a little hill. There's this blue line sticking out too, like as if it's been a javelin that's been stabbed into the ground here. But it's not. It's just treating the two sets of data, the two columns, as two bits of data here. So we're going to change that. So like I did last time, click on chart type. This time you'll see it's unticked. Use column C as labels. So column C is the second width. So if I tick that, it now takes the column C values and pops them down here. And what we'll do is, and we're choosing a smooth line graph. And under customization, we'll just do sort of similar things. So I'll just say pen A, like so. Turn the legend off, like so. And the other thing is that this is going to be the important one, because we can see from here I'm going to have a maximum area, and it'll even tell me if I just sort of like go along here, I can see that the maximum is there. So this graph here is a great visual to show how the area increases steadily up to a point and then decreases down to 0 again, the area does. So we can see very visually that the area is a maximum, is biggest in the center here. Now, from this graph, it's a bit difficult to see. So it's an important point though. So what we might do is we might go to the horizontal axis, and we might see if we can change. It's a bit tricky too, so I'm not going to spend too much time looking at it. I know the maximum is 0, minimum, sorry, and the maximum is 24. There we go, it's got 24 now. Oops. Okay, I liked it better as it was. There we go. It's a bit tricky, old Google spreadsheet sometimes. So now I've got my 12 in there, and that's probably enough. I mean, it'd be good if I could see the 144 here as well on my graph. But again, because I'm not actually using this graph in a doc report, a Word document or a Google Doc report, it's enough. As long as I can read it off from here, I'm good to go. So I'll click on Insert. There's my graph. I'll just shrink him a little bit and put him here. Okay, so that's it. That's the second graph done. Like so. There we go. We can see them side by side now. I haven't labeled these very well. So if I now go over to here, you basically, again, need to sketch the graph. There they are. You need to sketch this graph in this space here. And so it's worth, again, thinking, what do you think the critical points are? So you simply need to, in the graph, it's a sketch, so you just need to make sure the shape is about the same. okay, and that you've sketched the most important points. So have a think about what you think the important points are. And I'll pause for a sec. Pause the video if you need more time and to work out what you think the important points are. And let's see if you're right. Let's have a look at this graph. There we go. On this graph, there are really 3 critical points. The fact that it starts at 0 is important. That's where it cuts through, passes through the horizontal axis. The fact that it finishes at 24 is another important point. But critically for what we're doing here, putting the maximum of the graph, the maximum area, as being the coordinates 12, 144 is really important, because basically what this tells me is that when the width is 12, we have a maximum area of 144 square meters. Okay, so that's all the spreadsheeting done. You've copied everything that you need. You've made the graphs as you need. You've created your sketches, and now you just need to think a little bit about what it means, and that's how to end up pen A. Okay, so I don't need that spreadsheet anymore. But for pen B, there it is. I've given you the headings there, but none of the values in here at all. You have to work that out yourself from pen B. Then from pen C, I've given you the headings again. And then from pen D, all I've done is given you the headings as well. And the area for a triangle is half, or 0.5 times width times base. There's width, there's base. Okay, so that's the 4 pens. And I don't need the spreadsheets anymore for answering the rest of the questions on the page. You've got all the information you need here. Okay, so the next part of the question asks you, what is the greatest possible area of pen A? Well, we can get that off our graph. There it is there. So you should know already what this is going to be. Let's see if you're right. 144, and we've got our units in square meters. And at the bottom of this page, draw a diagram of pen A. Now on your handout, it's only a small space, but it's okay. It's only a rough diagram. So what is it then? When the area is, when the width is 12, you can read it off your spreadsheet, or you can go back here and work out what the length is. 24 take away 12. I'll just zoom that up. There's the length is equal to 24 take away 12. So when the width is 12, the length is 12. Well, what kind of rectangle has a length of 12 and a width of 12? So we don't normally call it a rectangle, but I guess it's a special form of a rectangle. So what is it? Give you a moment to think about it. Maybe draw it in yourself. And again, pause the YouTube if you need extra time. Okay, let's see if you're right. Here we go. A 12 by 12 rectangle is in fact a square. So that's basically it. That's how you do Don't Fence Me In. So that's the easy one in a sense. All you have to do now for pen B, pen C, and pen D is the same thing, except that obviously your mathematical modelling is going to be different. So if you call this width X, what's this length going to be? If you call this width X, what's this length going to be? And D is a bit different again, but it's the same idea. Okay, and you'll be guided through it a little bit through the worksheet. Okay, so I think that will do for you. Hopefully that's enough of an introduction to Don't Fence Me In to make it make sense. Try to make sure that your work is as much your own as you can, and good luck in finishing it. Bye for now.